All right, goal 9.5 is working with complex roots. Complex roots mean that you can take the square root of a negative. So the square root of a negative is equal to I. If you take that equation, the square root of -1 equals I, if you square both sides, you get -1 equals I squared. So two things are going to happen. One, we are not going to leave a negative under any radical at all. And two, we are going to not leave an I squared anywhere because I squared is equal to -1. So we can replace I squared with -1. All right, so the key thing on here is you must take the square root of the negative before you do an operation. So when we get to that question, I will emphasize that a lot for you so you can see that. All right, so the square root of -49. In terms of taking the square root of the numbers, you do it just like we did in goal 9.1. Okay. All right, so the square root of 49, let me get my blue pen here, is 7. And then the square root of the negative piece is I. So it's really that simple. The square root of a negative is equal to I. The square root of 49 is equal to 7. All right, so then we continue. 24, not a perfect square, breaks to 4 times 6. So the square root of 4 is 2. The square root of 6 I don't know. And then the square root of the negative is I. The negative square root of 25 over 81. The square root of 25 is 5. The square root of 81 is 9. And the square root of the negative piece is I. Or you can write this as 5I over 9 as well. The square root of 3 we don't know and it doesn't break down, so we leave it 3. The square root of the negative is I. $300, not a perfect square, breaks to 100 times 3. So I have my 5 that's out there. The square root of 100 is 10. The square root of 3 stays. The square root of the negative is I. And then that simplifies to 50. I square root 3. So take the 5 times 10 and multiply them together. 72, not a perfect square, but it breaks to 36 times 2. So I have my -6 out there. The square root of 36 is 6. The square root of 2 I don't know. And then the square root of the negative is I. And I multiply those and get -36I square root 2. So this is what I meant from up above in the notes where I said you must take the square root of the negative before you do the operation. So you've got to take the negative out before you multiply or add or subtract or divide. So I take this out first and I get I square root 7 and then I square root 3. So now I multiply. I times I is I squared. 7 times 3 is 21. 21 is not a perfect square. 21 doesn't have a square factor. So that's as simple as that part goes. But remember from above, I squared is equivalent to -1. So this answer is just -1 square root 21 or just negative square root 21. So the I squared makes it negative because I squared equals -1. All right, take the I out first. You got a negative out in front. So I have negative I square root 6 times, take the square root of that negative, I square root 12. So I get negative I squared. So that's a negative I times a positive I, negative I squared. 12 times 6 is 72. We just broke up 72. 36 times 2. So the square root of 36 is 6, so I have -6I squared, square root 2. Remember that I squared is just -1, so that's -6 times -1, square root 2, or +6 square root 2. So I don't really need to show this step where I place the -1 in here because I know that I squared is negative, and all it's going to do is make this sign, whatever that number is, the opposite. But feel free to do that. Feel free to put in that -1 though, if you want. Sorry, I'm trying to scroll my screen. I'm just making marks. All right. These are perfect squares, so I can go ahead and square root them. So I have negative. Square root of 25 is 5. The square root of negative is I. Negative, the square root of 9 is 3. The square root of the negative is I. I then multiply. Negative 5i times negative 3i is a positive 15i squared. Remember that I squared is just -1, so that means -15. Here I need to take the square root of that I first. Oops. So I have I square root 3 times I square root 12. So I multiply. I times I is I squared. 12 times 3 is 36. 36 is a perfect square is 6, so I have 6i squared, which again, just remember, that is a -1, so it just means -6. So anytime, once again, I squared is attached to a number, it just changes the sign. So positive 6i squared becomes -6. If it said negative 7i squared, it would be positive 7. All right, so we can add. When we add and subtract, we treat them like they're variables, like x's and y's. So I can add 5 and -7 is -2, 6i and 2i is 8i. Now we can leave answers with i's in them, just not answers with I squareds. So that is my final answer. I can't simplify that any more than that. If I am subtracting, I do need to distribute that negative. So this becomes positive, this becomes a negative. So -7 and positive 5 is -2i. 8 and -1 is positive 7. Order does not matter. 7i times 6i, 42i squared, which remember we just said I squared just makes it negative, so that's -42. 3 times 10i, 30i. We can leave an I, we just can't leave an I squared, so that's my final answer. -4i squared means -4i times -4i, which is positive 16i squared. I squared is -1, so that just means this is -16. Here I have a FOIL. You should recognize FOIL, 2 terms, 2 terms. First times first, 12. Outer times outer, -15i. Inner times inner, positive 4i. Last times last, -5i squared. So let's remember here now, can't leave that. If it says -5i squared, it's actually positive 5. And then 12 and 5 is 17, -15 and positive 4, -11i. All right, just like you can't leave a radical in a denominator, you can't leave an I in a denominator. So here I'm going to multiply by I over I. To get rid of I, you multiply by I. Distribute. 8 times I is 8i. 3i times I, 3i squared. I times I squared. So remember, I squared is just -1. So this becomes 8i minus 3 over I squared is just -1. Now you can leave your answer like that, but more likely than not, if this answer were in a math book, they would leave it like this. They would take -1 into both of those. I really have no preference, so you can do either way for me. I don't care. You can leave the -1 on the bottom. All right, and then last example. Just like radicals, if I have an I with addition or subtraction like this, I need to use the conjugate. I should have wrote that in pink because we are rationalizing the denominator. So remember, the conjugate is the same thing with the opposite sign in the middle. So again, I have to use the conjugate here because I have addition, or it could be subtraction with the I. In the numerator, I'm going to FOIL. First times first, negative 16. Outer times outer, negative 56I. Inner times inner, positive 6I. And last times last, positive 21I squared. Over. Just like with the radicals, you're using a conjugate. You do not need to do the whole FOIL, just first and last. So first times first, negative 2 times negative 2. Last times last, minus 49I squared. All right, so these can be simplified. Plus 21I squared is actually just minus 21. And minus 49I squared is actually positive 49. So I end up with negative 16 and negative 21, negative 37, negative 56I and positive 6I is minus 50I, and then 4 plus 49, 53. So like the radicals, we're going to check to see if we can reduce this. If those three numbers are divisible by a common factor other than 1, then you can reduce. But there is not a number other than 1 that goes into all three of those numbers. So that is your final answer. So there's a lot of similarities with the radicals in terms of rationalizing. You can't leave an I in the denominator. You have to use a conjugate when you have plus and minus. So lots of things. So the key things are, don't leave a negative under the radical. Bring it out and it's equal to I. And then always replace I squared with negative 1.